if you want to swim forward, what do you actually do? You push the water backward. It's like a completely everyday action, but when you stop to really think about the mechanics of it, it's a fascinating little mystery.
It really is.
Right. So today we're taking a deep dive into this hidden engine behind movement, which is Newton's third law. We're going to completely change how you view everyday actions, starting with, well, the biggest illusion of all. The idea that equal and opposite forces somehow cancel each other out.
That is honestly the perfect place to start. The golden rule of this law is that physical forces, they never exist in isolation. They always come in pairs.
Right.
So when object A exerts a force on object B exerts an equal and opposite force right back on object A.
Okay, so let's picture this in the wild. Think about walking down the street. Your foot pushes backward on the pavement, so what is physically pushing you forward?
It's the pavement. The ground is actually pushing forward on your foot.
Oh.
Yeah, and that highlights the absolute most crucial part of this concept. These paired action-reaction forces, they are acting on entirely different objects, your foot and the ground.
It's the same invisible engine behind a rocket launch, right?
Yeah.
I mean, the rocket doesn't push off the launch pad to get to space. The engine pushes gas downward, and then that downward gas pushes the rocket upward.
Exactly. And even something completely static, like a book resting on a desk.
Right, the book pushes down on the wood.
And the wood pushes up on the book.
Mm.
It is a constant universal exchange.
Okay, but here is where my brain hits a wall, literally. If I push a brick wall and that wall pushes me back with the exact same amount of force, why don't those two forces just, equal zero? Why doesn't everything just freeze?
That is the most common trap people fall into.
Because it just feels like moving $10 from my left pocket to my right pocket. The net change is zero.
But your pocket analogy actually gives away the answer. It's not moving money between your own pockets.
Oh, it's not.
No, think of it like bank accounts. If you transfer $10 to me, your account balance goes down and my account balance goes up. The total money in the world didn't cancel out to zero because the changes happened in two completely different accounts.
Because my pushing force acts on the wall and the wall's pushing force acts on me.
Spot on.
So they don't cancel out because they aren't acting on the same thing.
You're thinking of balanced forces. Balanced forces can absolutely cancel out to zero, but that is because they are two different forces acting on the exact same object.
Like two people pushing a heavy box from opposite sides.
Exactly. Action-reaction pairs act on different objects. They never cancel each other out.
That distinction clears up so much. But let's look at the timing of this exchange. Because if I kick a soccer ball, my action happens first, and then the ball's reaction force hits my foot a millisecond later, right?
Actually, no. That is another huge misconception. They happen at the exact same instant.
Wait, really? No delay at all?
None. They aren't two sequential events. They are two halves of a single interaction. You physically cannot touch the ball without the ball touching you back in that exact same millisecond.
Okay, so it's a simultaneous mutual exchange. But what if there's a massive size difference?
What do you mean?
Well, let's say I jump out of an airplane. Gravity is pulling me down, meaning I am pulling the Earth up. But the Earth is massive. Surely it exerts a bigger force on me than I do on it.
Believe it or not, the force magnitude is perfectly equal.
Come on.
Seriously. You pull on the Earth with the exact same force that it pulls on you.
Wait, if the force is exactly equal, why am I the one plummeting through the sky while the Earth doesn't seem to budge? If forces are equal, shouldn't our movement be equal?
Not at all, because movement isn't just about force, it's about mass.
Oh, right.
Yeah, since your mass is tiny compared to the Earth, that equal force sends you accelerating downward incredibly fast. But the Earth's mass is astronomically huge.
So that exact same amount of force produces an acceleration so incredibly tiny, it's practically zero.
Exactly. Equal forces do not mean equal effects.
Wow. So if you want to spot these force pairs hiding in plain sight, there's like a checklist, right?
Yeah, a simple four-step check. Are two objects interacting? Is one exerting force on the other? Is the other exerting equal and opposite force back? And are they acting on different objects?
Right. And once you realize these forces never act on the same object, you really start seeing the mechanics of the matrix everywhere.
It completely reframes how you interact with the physical world. You stop seeing single actions and start seeing mutual exchanges.
It's brilliant. And it leads to a pretty mind-bending takeaway. Building on that walking example we talked about earlier,
Yeah.
the next time you take a simple step forward, consider this. Because forces are equal and opposite, as you push backward on the ground to move yourself forward, you are technically pushing the entire planet Earth backward.